Oh, it's time to connect with Norm Tucker.
Hi Norm, what type of heat treatment secret are you going to discover for us today?
All right, so I'm thinking Austempering in a vacuum furnace. It's a unique process and it's very rarely done, and I've actually perfected it. Very works a treat.
Yeah, Austempering in a vacuum furnace. That sounds very intriguing.
Yeah, it's deviating away from the traditional methods of using salt, and as we know, salt these days is very hard to control.
Okay, let's back up for a second. Norm Tucker, Heat Treatment Australia. Can you tell us a little bit about yourself and your career?
Oh wow, okay. I think this is my 35th year in heat treatment. Started as a kid, probably about 5 years old, I think. Yeah, with mum and dad coming into work, and from there I started full time when I was like 18, and been here since, and learned the trade from the ground up. Yeah, family business. Mum and dad started it back in '74, and they started off with a couple of old salt baths and homemade back then, and progressed all the way up to today, where we're running vacuum furnaces and atmosphere furnaces, and you name it, we have it.
Yeah, how big of the company you are right now?
We have 4 sites across, well, 3 sites across Australia and one new one in the USA. We employ approximately 75 people, I think, somewhere around about that, and growing quite rapidly the last couple of years.
That's awesome. I'm having my coffee, Norm. What are you drinking today?
Oh, I've got coffee. It's not beer. It's about beer o'clock, but it's not beer.
Yeah, so we are here from Świebodzin, Poland. Norm is out there in Brisbane, Australia. People can type in the chat window where you're connecting from. That would be interesting to see where you are located all over the world. It will be very exciting to see in a chat window. Okay, so let's back to the main subject, Austempering. Now, I would like to be a student, and if you could be my teacher and tell me more about Austempering, what it is and why we use it.
Okay, all right, Austempering. Why do we do it? Austempering, it replaces conventional quench and temper products. I would choose Austempering if I want to reduce distortion on a component. If I'm getting a high level of distortion from the quench, and it may be usually a fast quench like oil, we'll go for an Austempering process where it kind of suspends the heating, the cooling process at around about 350 degrees. It significantly reduces distortion. That's one benefit, but the real benefit is we're enabled to get a higher hardness and still maintain the mechanical properties that a quench and tempered process would give us, and in fact, more properties.
It sounds like it is very similar to isothermal quenching, or is it?
No. Yes and no. Isothermal quenching is still letting you achieve a martensitic microstructure. It kind of suspends it and lets everything equalize thin sections to thick sections, and then you slowly cool down through the range, producing less stress in the component. By Austempering, you're actually transforming the microstructure to a magnetic microstructure at that point. What you do after that is what you feel like. You can air cool, you can force cool it, whatever. It won't change the hardness and the properties.
So how can you realize this in a vacuum furnace?
So it's a traditional heat. Let's say you're running 4340, it's a high tensile grade, common here in Australia and around the world. We'll heat it up, around 850, 870 degrees Celsius. We'll hold it until we form austenite, which will be, somewhere around a half an hour to an hour, depends on the component section. And then we'll cool it fast, very, very fast, down to 350, and suspend that, hold it. at 350 Celsius for an hour, and then after that, it's just a very slow cool after that, and it's done. There's no tempering after it. You can send the part out and be confident it'll be right.
So do you extend that isothermal step
Yes.
with heating, with convection heating, or you just
convection heating
at the temperature?
At least, and usually at least 1 hour too.
Okay.
1 hour. After an hour, the benefits are very low. So the whole process takes about 5 hours.
What quenching pressure and what quenching gas you use in case of Austempering?
Nitrogen being the cheapest and readily available. And the quenching pressure, I've experimented with 2 atmospheres up all the way up to 15. And it really comes down to the section size of the component and how many components you have in there. So usually, 5 to 7 bar would suffice.
Yeah, you mentioned some steel grades. Is it 4320?
Yes.
So
yeah,
what
43.
other alloys can be used for this process? Other way, for which alloys this process is good?
Other materials. Well, you could use materials called high tough or 300M or any material that will form bainite around 300 to 400 Celsius, and that's usually the high strength alloys.
Mm-hmm. And if you could tell us to which parts, what type of parts are the most common when you use Austempering? Yeah,
well, again, that goes back to some customers may not even require Austempering, but it's reducing the distortion, which is the benefit of this. So you might do couplings or transfer shafts or power takeoff shafts, and that's actually a good one because that's they're on a very high load and usually want a fairly good hardness.
Yeah, so those are parts which are difficult from the distortion standpoint.
Yeah, exactly. Especially if it's you have internal splines or internal sleeves or gears cut internally. As you know, that would create a lot of distortion as it transforms into the martensitic structure. So this way we get away from it, and we're getting a faster turnaround on product, and it comes out clean and higher hardness if the customer requires it.
Yeah, you mentioned one very important thing. It's faster turnaround. So
it's faster turnaround. Yes.
How much time in average can you save with using Austempering versus regular heat treatment?
I honestly think you'd be at least 30 to 40% faster.
Okay, that's a big saving. You can heat treat 30 to 40% more parts every year. That's
really, yeah, absolutely. And don't forget the labour content. You're not having to after the quenchant, remove it and clean it and put it in a tempering furnace. It takes time and money.
Sure. And you don't need these additional furnaces, right?
Yeah.
So we started about benefits of that because saving time, you require less equipment for heat treatment. What other benefits can the customer have from this technology?
It's automation. That's the key. Once the recipe's set, you really can forget it and reproduce this every time around. You're not having any interrupted quenches, and as you remove parts from a quenchant, from a hardening to a quenchant, etc., or a quench delay, that doesn't exist anymore. Quench cracking is virtually eliminated. There's many benefits.
And the difference from traditional Austempering, which was done in salt baths, and versus vacuum furnaces, as you said, it's complete automation, right? Because the other process was
absolutely. We've had salt. We use salt for many years, and it's a wonderful process. It really is, and you get a good product every time, but it required a lot of manual labour, and following that, you have disposal costs of the salts and everything else that goes with this.
Not to mention the environmental impact.
Yeah, it's huge, huge. When you come to a vacuum furnace, what do you have? You're using nitrogen for a quenching.
That's pretty much.
Yeah.
No, so if it goes to your customers, usually the customer comes to your heat treat shop and asks you a question. Let's say, how much it will cost me to heat treat these parts? We have so many of these parts per month, so many of these parts per week. What's the logic behind it? How you determine which technology you can apply, whether it's regular heat treatment or Austempering specifically in this case?
Yeah. Well, always comes down to one thing: price, right? But will the cheapest price provide the heat treatment and the outcome that's required for the part? And sometimes a lot of times it actually is. A simple, say, quench and temper from an atmosphere furnace of a low carbon or a medium carbon steel will do the job. Now let's consider the outcome may not be desired. The part may distort. For example, it might be a long shaft, and if we oil quench that shaft, it'll be able to go around the corner by itself, right? We don't want that. We want a straight shaft as best as possible without any after post works. And so we'll then select a vacuum or a process of some sorts, and even that might be just a standard quench and temper in a vacuum. And then if the alloy is suitable for the process of Austempering or isothermal hold or whatever the case may be, we would be able to select that. But it also comes down to quantities. You really couldn't Austemper in a vacuum furnace for one piece. You would need some sort of quantities, and it'll be a repetitive quantity in that, because there's always a testing phase that goes along with the first off these components.
So if I bring you one piece which will theoretically qualify for Austempering process, you need to do some the legwork to exercise the process before we actually put that part into the furnace.
Absolutely.
That's very important to say.
Yeah, it's very important. There's a mass and there's a heat load in the furnace, and we have to know what that is. Well, we have a fairly good idea, but we need to be precise in the cooling process and the stabilization at that Austempering temperature. And it's not really feasible for one piece. Once you have the component that you've chosen that to heat treat, you can look into the theory behind Austempering of that material, using that material and that dimensions and so forth. And I would suggest you contact your local heat treater and talk to them about it and see what they can offer. It's a great process and it works, and it'll save you a lot of money.
All this blog is about uncovering secrets of heat treatment. What's your opinion? How many more secrets will be uncovered in the future in the heat treat reality, in the heat treat life?
Oh, jeez, I got heaps to tell you, but I can't. There are many. Okay. Technology's been that quick. You put your mind to an application, it will come out. It's amazing what's out there.
Okay, thank you, Norm, for telling us about secrets of Austempering. You just confirmed that if we need good information about heat treatment, you are the reliable source. So once again, thank you very much, and you have a good night over there in Brisbane.
Oh, well, yeah, I will, and thank you for asking. It's been wonderful. Thank you.
Bye-bye.
Bye.